Hi students, this is Naveen. Today I am going to explain Kirchhoff's voltage law. Why we are going to learn Kirchhoff voltage law? With the help of Kirchhoff voltage law, we are able to find out the unknown values of the current as well as voltage in a given complex electric circuits. In some cases, we are unable to use Ohm's law alone. In that case, with the help of KVL as well as KCL, we are able to find out unknown values in a complex circuit. Now, the KVL is also called as a Loop's law. The Kirchhoff's voltage law states that the algebraic sum of changes in potential in any closed loop of an electric circuit is equal to 0. Simple. The algebraic sum of changes in potential or the algebraic sum of potential differences in any closed loop of an electric circuit is equal to 0. It states that if there is an electric circuit, there is a closed loop. In that loop, the algebraic sum of all the potential differences is equal to 0. How to apply this law to the circuits? For that, I will take one circuit here. One resistor connected to the cell. This is the EMF of the cell E1. Here I will connect one more resistor, another cell. Here I can connect another resistor. Let us assume the resistance value R1, R2, R3, and the cell having EMF E1, this cell having EMF E2. Now, how to apply the KVL to this circuit? First of all, you have to check this is the loop or not. In electric circuit, in simple terms, loop means a closed conducting path. This is a closed path. This is a closed circuit, and this is the conducting path. If suppose the current is passing in the circuit from higher potential of this cell to the lower potential of this cell, the current passing through along this loop, you can consider this is a closed path and it is having a conducting path. It is a electric circuit. Now, in this circuit, the algebraic sum of changes in potential is equal to 0. For that, if suppose if I am starting from here and I will passing through this resistor and I will move from resistor to EMF E1, after that resistance R2, after that R3, after that EMF E2, and finally I go to the same point. Let us assume this is the point A, B, C, D. Here, what is the loop here? A, B, C, D, A. This is the loop in the electric circuit. In this loop, the changes in potential is equal to 0. The current is flowing in this direction. If I am moving in this direction, nothing but if I am moving in clockwise direction, this is the direction of loop, or we can say that the traversing direction. This is the direction of loop, or we can say that the traversing direction. It is clear. If I am moving through the resistor, what will happen? The current is moving from, we know that the current is always flow from higher potential to lower potential. Let us assume this is the higher potential, lower potential. This is the positive terminal, negative terminal. Here also higher potential to lower potential, plus 2 minus. Here also higher potential to lower potential, plus 2 minus. Here it is having positive terminal and negative terminal. Is that clear? The current is passing from higher potential to lower potential. The traversing direction means which direction we are moving around the loop, that is considered as a traversing direction. The direction and current both are in same, it is moving from higher to lower. Higher to lower means this is the higher potential, this is the lower potential. If you move from higher to lower means there is a potential drop, nothing but if you are moving through the resistor R1, the traversing direction, current both are in same direction, it will going from higher to lower, there is a drop in potential, it will becomes minus. What is the potential difference? We can written as according to Ohm's law, V is equal to I into R1. Nothing but higher potential, we are traveling higher potential to lower potential. The traversing direction higher to lower, there is potential drop, it will becomes minus IR1. Next one, the algebraic sum of, we have to add remaining EMFs and resistance also. And here, this is the higher potential, this is the lower potential, it is having two terminals, one is having higher potential, one is having lower potential, higher to lower, the current passing from higher to lower. Here also higher to lower, it will becomes negative. Here also there is a drop in potential E1, and here higher to lower, we are moving in this direction only. The current also moving in the same direction only. Here also there is a potential drop minus I into R2. In same way here we are moving in clockwise direction. Both directions are same, higher to lower. Here also there is a potential drop. I can written as I into R3. Here it will passing from lower to higher. Lower potential plate to higher potential plate. Here the potential is rises in potential. Nothing but we can write plus E2 is equal to 0. Like that we have to write the equation for the given loop of a electric circuit. With the help of this equation we are able to find out unknown values given in the circuit. Now you have a confusion, sir, how to write which one is negative, which one is positive, we are having so much confusion, sir. For that we have to know about the sign conventions. For that you have to know about the sign conventions. By knowing sign conventions you can easily write the equations. What the sign conventions means, there is a resistor, and the current flowing in this direction, let us assume I, the resistor is R. The traversing direction, we are moving in this direction. Here it is a clockwise direction. If both directions are same, we know that the current is passing from higher to lower. If the both directions are same, let us assume if both directions are same, the potential difference, let us assume this is VA, this is VB. Here what is the potential difference? We are moving in this direction, VA minus, it will be high to lower, both are in same direction means minus IR1 is equal to VB. Remember, this is a resistor, here the element is resistor, the current direction and traversing direction both are same, it is become negative. This is a higher potential VA, there is a potential drop minus IR1 is equal to VB. We can also written as the potential difference is equal to minus IR1. Nothing but we can simply written as the potential difference VB minus VA is equal to minus IR1. Is that clear? In another case, let us assume this is a resistor R and this is the current direction and we are moving in opposite to current direction. This is our traversing direction. In same way, this is VA, this is VB. How to write this one? If both are in opposite, we are starting from here. VB minus VA is equal to, otherwise you can write a VB. If both are in opposite means there is a rise in potential. We can write written as VB plus the current is I. VB plus IR is equal to VA. Is that clear? If both are opposite, it will become positive. VB plus IR is equal to VA. From this, how to write? VB minus VA is equal to minus IR. Here, what is the potential difference? We are starting from here. I can written as VA minus VB is equal to IR. If you have a confusion, just remember, for better understanding, just remember, let us assume the potential difference is V. Here, if both directions are same, I can write minus IR. Here V is the potential difference. Simple. Here both directions are opposite to each other. V is equal to IR. And in same way, if I am taking cell, the EMF of the cell E1, this is positive terminal, this is the negative terminal. We are moving in this direction. Now traversing direction in this way, let us assume here to here the potential difference delta V is equal to positive to negative, there is a potential drop minus E1. Instead of VB minus VA, I can write directly V. V we can consider as a potential difference. If both directions are same, it will become negative. If both directions are opposite, it is positive. Both directions means, what are the directions? One is our assumption, our traversing direction, one is the current direction. If both are opposite to each other, V is equal to IR. If both are same, V is equal to minus IR. Instead of VA minus VB, I can directly write V, where V is equal to potential difference or change in potential. Is that clear? In same way, if suppose if you are moving from negative terminal of cell to the positive terminal of the cell, it will becomes the change in potential V is equal to E. It is moving from negative potential to higher potential, it is positive. If it is moving from higher potential to lower potential, it is negative. Our traversing direction and current direction both are same, it is negative. V is equal to minus IR, where V is the potential difference. For better understanding, I will remove VB minus VA. Don't confuse. For reducing the confusion, first you have to learn like this. After that, I will explain in open circuit how we can apply VB minus VA, VA minus VB. These are all things. And is that clear? Now, like in same way, we are applying the same sign conventions to the given circuit. Already you know the equation of this circuit. I will change this circuit. We will take one example circuit and we are try to write the equations. Let us assume I will connect the two cells like this, and I will use the three resistors here. The first cell, the EMF of the first cells, let us consider 10 volts. The second cell, let us consider 4 volts, and here the resistance 1 ohm, 2 ohm, and 3 ohm. Now this is the given circuit. Now we have to find out how much current flowing through the circuit. Before going to apply the loop law, we have to find out the current direction. How to find out the current direction? If you compare these two potential differences or these two EMF, the 10 volts is greater than 4 volts, I can consider the current is moving in this direction. Higher potential of the 10 volts cell to lower potential of the 10 volts cell. Is that clear? Nothing but the current direction like this, the current is I. Now, how to find out the current value? Now, if we are moving from this point to, let us assume A to B, B to C, C to D. Now, if the traversing direction is in a clockwise direction, if you take anti-clockwise also, no problem at all. Now, the current direction and traversing for the first resistor, this is the 1 ohm resistor, this is the current I, and this is our traversing direction. These two directions are same. The two directions are same means what I have to take here? The potential difference, the change in potential is negative, minus IR. Here I is equal to current I into R1, and after that here the traversing direction, negative terminal of the cell to positive terminal of the cell. How can I write this one? Here negative potential plate to positive potential and lower potential to higher potential, I can write plus 10. And for the next resistor, this is our traversing direction and this is current direction I. What is the resistance here? 2 ohms. Here this is 10 volts. Resistance here 2 ohms. How can I write? It will be minus, before that one more EMF, one more cell is also there. This is a 4 volt cell. Here this is the traversing direction, higher potential, lower potential. It will becomes, this is 4 volts and another resistor, and current direction and traversing direction both are same. This is the current direction. See, if you observe, the current direction, traversing direction both are same. It is also become negative, minus 3 into current I. How can I write the equation? See, 1 into I, this is IR, I into R, 1 into I, minus I into 1, plus minus 2 plus 10. Here it will becomes, both directions are same. I can write 2 into, what is the current? I. Here it is positive terminal to negative terminal. It will becomes higher to lower. It will becomes minus 4. Here both are same. I can written as minus 3I is equal to 0. According to the KVL statement, how can I write? Minus I plus 10 minus 2I minus 4 minus 3I is equal to 0. From this, minus 3I minus 2I minus I, 3, 5, 6 minus 6I plus 10 minus 4, 6 is equal to 0. From this, how can I write? 6I is equal to 6, I is equal to 6 by 6. Therefore, we got I is equal to, what is the value of I here? 1 ampere. Finally, you got I is equal to 1 ampere. Is that clear? First of all, we have to find out the current direction in the circuit. After that, we have to consider the direction, whether it is a clockwise direction or anti-clockwise direction. After that, we have to use the sign convention. With the help of the sign convention, we get the current. Here current I is equal to 1 ampere. Is that clear? Like this, we are going to apply the KVL to any circuit. Is that clear? For better understanding, I will explain one more circuit. I'll take one more circuit, and this is the cell, one resistor, one more resistor. I can connect this resistor to the another cell. Let us assume this is 15 volts, this is 30 volts. Here 3 ohms, 3 ohms, 6 ohms. Now we are going to find out the current flowing through a given circuit. This is the given circuit. How to find out current flowing through a given circuit with the help of KVL? How to find out? For that, we have to know the current direction. You can take any one cell. If you take 15 volts or 30 volts, you can take any one cell. Let us assume the current passing through the 15 volt cell. Let us assume that is I1. That is assumption. You can take 30 volts also, no problem at all. And the current passing from here to here, if you observe, this is the junction point. According to KCL, what will happen? The sum of the incoming currents is equal to sum of the outgoing currents. Here the I1 is passing through here. Here I2 is passing. Here what is the this how much current passing here? I1 minus I2. Here I1 minus I2 passing here, I1 minus I2. Here the I2 is coming here. I1 minus I2 plus I2. Here you got I1. The total KCL condition is satisfied. If you are observe junction point here B, the sum of the incoming currents. What are the incoming currents here? I1. By applying KCL at junction B. By applying KCL, sum of the incoming currents, what are the incoming currents? I1 is equal to, what are the leaving currents? I2 plus I1 minus I2. Is that clear? Now, I2, both are cancel each other. I1 is equal to I1. Here, the junction line is satisfied. And coming to the another junction, if you are applying KCL at junction D, here also the I1 minus I2, this is the incoming current, and this is also incoming current. I2 cancel. Here we left with I1. The junction line is satisfied. You have to take any direction of the current from any EMF, any cell, but it must be satisfied the KCL at junction point. Is that clear? Now the junction line is satisfied. Now we are going to apply the loop law. I will take the traversing direction in clockwise direction here. Here also I will take clockwise direction. First, how many loops are there? 1, 2, 3. How many unknown values are there? I1, I2. The unknown values, how many unknown values you want? That many equations is required. How many unknown values are there? 2 unknown values. 2 linearly dependent equations are sufficient for solving the problem. Now, let us assume A, B, C, D. Just applying KVL to loop, first loop A, B, D, A. If you apply KVL to this loop, how to write? This is our traversing direction. This is the current direction. Both are same. Both are same means it will becomes minus here resistance 6. According to Ohm's law, I into R is equal to V. Minus 6 is the resistance. Current is the I1. And if you consider here, we are moving in this direction. This both directions are same. Here also minus, what the resistance? 3 into I2, and we are go through this direction, and here this is our direction, negative terminal to positive terminal, it will becomes plus 15 is equal to 0. From this, how can I write? Minus 6I1 minus 3I2 is equal to minus 15. It is also written as the 6 and 15. It is multiples of 3. I can also written as minus 2I1, 3 1 are 3, minus I2 is equal to minus 15. We can finally written this one as I2 minus I2. See, these two are minus, it will become plus 2I1 plus I2 is equal to 15. Let us assume this is equation 1. Is that clear? For loop ABDA, this is the equation 2I1 plus I2 is equal to 15. And in same way, I have to apply the KVL to the loop BCDB. Applying KVL to loop BCDB. Now, if you observe, the two directions are same. These two directions are same means how to write the traversing direction and the current direction both are same. I can written as minus the resistance 3 into or the current here I1 minus I2. If you observe, it is passing from positive terminal to negative terminal. How can I write minus 30? And here, if you observe, this is our direction, this is the current direction. Both are opposite to each other. Opposite to each other means the change in potential is becomes positive, nothing but plus. Here 3 into I2 is equal to 0. How can I write this one? Minus 3I1 minus minus plus 3I2 minus 30 plus 3I2 is equal to 0. If I transpose the 30 here, plus 3I2 plus 3I2 6I2 minus 3I1 plus 6I2 is equal to 30. See, minus 3I1 plus 3I2 plus 6I2 is equal to 30. This is also multiple of 3. You can rewritten as minus I1 plus 2I2 is equal to, here it will becomes 3, 5 is 15 minus 5. Here it is also 5 and here 3 10 jump. I will write 10 here. Here I got two equations, equation 1 and equation 2. Now, by solving the two equations, we are able to find out current I1 and I2. How to solve the equations? If you observe, this is minus I1, this is 2I1. If I multiply this equation with the 2, it will becomes equation with 2 becomes minus 2I1 plus 4I2 is equal to 20. And this equation 2I1 plus I2 is equal to 5. Now, this is, if I add these two equations, I want to multiply the second equation with 2, it will become minus 2I1 plus 2 into 2 4I2 is equal to 20. And I will add the first equation to this equation. I will add these two equations. Minus 2I1 plus 2I1 cancel. Remaining 4I1 plus I2, 4I2 plus I2, 5I2 is equal to, here 20 plus 5, 25. Therefore, I2 is equal to 25 by 5. Therefore, I2 is equal to 5 amperes. I got the current I2. The current I2, nothing but the current flowing through the 3 ohms is 5 amperes. By this, how to find out the current I1? By using this equation, 2 into I1, I already know the value of I2. I2 is equal to 5. is equal to 5. Therefore 2i1 is equal to 5 minus 5, 0. 2i1 is equal to 0. Nothing but it will show that i1 is equal to 0. Is that clear? Like this, you have to find out the currents in a circuit with the help of KVL. The current I1 becomes 0. I1 is equal to 0. I2 is equal to 5 amperes. This is just for example. Like this, you have to utilize KVL to the given circuits. By applying KVL, you can find out the unknown values of current and potential difference in a complex circuits. Is that clear? Thank you. Thank you all of you.